Welcome to AI Shorts, the show where we talk about the intersection of machine learning and product management. In the last episode, we discussed data types and storage. Today, we'll continue to develop our data science knowledge and develop a foundation upon which we can build. So let's talk about exploratory data analysis, better known as EDA. When we get a new data set, we need to understand what the data looks like to determine the appropriate pre-processing and feature engineering steps. There are three things that we need to look at in our data: relationships, distributions, and data quality issues. Let's discuss each category and what we're looking for. I'll assume you're using Python, and I'll give you suggestions for functions and libraries you want to check out. When analyzing a new data set, one of the first things you want to do is understand the relationships between the different variables. There are a couple different ways to do this. The first thing you want to do is get some descriptive statistics using the describe function in Python. This will give you a summary of the data set statistics such as mean, median, mode, variance, and standard deviation. These statistics can provide insights into the data's central tendency, variability, and distribution. You can also do a correlation analysis with a core function. This involves computing correlation coefficients between pairs of variables. Correlation analysis can help you identify the strength and if your variables have a positive or negative correlation. Suppose a variable has little or no correlation. In that case, you might want to omit it from your data set depending on the problem that you're working on. We'll talk more about this when we discuss feature engineering. Suppose you want to visualize the relationship between two variables. You can create scatter or bubble plots using the matplotlib, plotly, or my favorite, the Seaborn visualization libraries. There are many examples on the internet and YouTube on how to use these libraries. After understanding the variable relationships, we want to take a look at the variable distributions. We do this with histograms and box plots. To create histograms, you can use the hist function in Python. First, the histogram will let us know what feature engineering techniques will be most appropriate. Second, we're also looking for outliers in our data, which can mess up our machine learning model. Data scientists can then decide whether to remove, transform, or handle outliers in another way. Outliers and the way we handle outliers can have a significant impact on your machine learning model. We'll talk about this in a future video. Finally, we want to understand any data quality issues. Here we're looking for missing values. If a value is missing, we can either remove the row of data with the missing value, or we can try to replace the missing value. Generally, we try to avoid removing rows of data as that can weaken our model. Instead, we can replace the missing values with the mean, median, or mode. We can also try to predict the missing value, which will probably give us the best result, but will take the most time to implement. Therefore, it's something that we wouldn't want to do when creating a new model, but it might be something we want to come back to in the future if trying to improve upon our results. We just skimmed the surface of EDA, but I hope you'll grab a data set and try out some of these techniques on your own. There are many specialty Python libraries specifically for EDA that you can find via Google. The best way to learn is to get your hands dirty and play around in Python. Next time we'll talk about feature engineering, what it is and why it's important. See you next time.